Hello and welcome to Chapter 2, Psychological Research. First, before you do anything else, I want you to pause the video and go step on a scale. Really, go do this. Get your weight and remember the number, write it down if you have to. In fact, I recommend you write it down. And then when you've got that done, come back and restart the video. Good. I expect that you did that now and you have a number that you don't have to reveal to anyone. I know I would not want to reveal mine. What we're going to be doing now is talking about why we take a scientific approach to gathering data about the world. It's necessary because there are certain cognitive limitations that make our casual observations about the world simply insufficient. Well, what do I mean by cognitive limitations? What do we mean by that? Our brains are not designed to carefully observe the world and make good scientific inferences. Oh, don't worry, we make plenty of inferences about the world, but because our brains were evolved to keep us safe, feed us, and make sure we reproduced, our brains are kind of biased to seek out those things which will create success for that, and not particularly well biased towards systematic, careful observation that is needed. Now, I want you to be aware when we use the word bias in psychology, we don't mean it in the conventional language terms, meaning that someone has an ill will towards others, is treating them bad, the ideas behind racial or gender bias. While our cognitive biases do sometimes enter into the reasons we have those kinds of biases against people, we're talking about more general processes that affect our thinking such that we don't see the world entirely accurately, don't store our information about the world entirely accurately, and don't recall information about the world entirely accurately. So, for us to be able to make good data collection work and to apply that appropriately to theories, we have to do systematic observation. We have to record things carefully, and we have to do analysis that is also systematically applied, because to do it any other way is going to lead us astray in our thinking. Even with those systems in place, we are often led astray. Our goal always is to understand how and what works in this world. We want to become appreciative of the nature of how the world works and be able to communicate it well. In your book, it talks about the DARE program, which when it was created was a really well-intentioned idea by police officers and educators to stem a growing tide of drug problems that have been recognized in this country, especially among school-age kids. The program was started in Los Angeles. It spread all over the nation and, in fact, to a lot of areas of the world. But what was found over time is that it was actually rather ineffective. It did not do a good job of making people really aware of what the issues were in drug use, how to avoid drugs, and why they were bad for you. And so these well-intentioned efforts were actually not doing a good job, but a great deal of public money was being spent on it. And so now your book kind of stops there and leaves you with the impression that the DARE program is inherently bad or doesn't work or is a waste of money. And in the old DARE program, that would be probably a fair assessment. But starting in about 2009, the board of directors of DARE brought in some people that were well versed in research. They understood the kinds of things that were effective in intervening and getting kids to adjust their thinking and to make better decisions. And they revised their program over time. And the current version is called Keeping It Real, which I'll say they really ought to work on the name because that's going to become a bit of a cliche in a few years, without a doubt. With that said, the Keeping It Real program is considered very effective. There's plenty of data to support and being developed that shows that it is better at not only affecting kids thinking about drug use, but also a variety of other things they can get involved in, which can cause them problems and success in life, and to avoid bullying and numerous other problems of childhood and adulthood. And so we have, by applying research, made a difference in a very practical problem that can have grave effects on people's lives. So, where does this come from, this movement from a DARE program to a new program that's more effective? Well, it all comes from the application of psychological theories. But the theories don't come from nowhere. The theories come from from examination of data and trying to understand how the data goes together. This theory data cycle is a never ending process. And what we're doing with our data is revising our theories, refining them, making them work better to develop more tuned research questions. Research designs are applied to analyze these questions with hypotheses that we collect data to answer and address. And if we get support, then our theory is stronger. And if we get a lack of support, then we revise the theory. We make sure our research design is appropriate. Now, this graphic here is simply a more complicated version of the graphic that is in your textbook, which I hope will refine your thinking a little bit on this as you examine it. So, what is the scientific approach? Well, scientists are empiricists. That means that they observe the world for objective data, which they use to create and revise theories to try to explain how the world works. In this way, psychological sciences are no different than all other scientists. We are doing the same thing. We're observing the world for the best objective data we can gather, and we're using it to revise our theories and to create them and to try to explain how does the world work. And in the particular case that we're interested in, the world of our minds and behaviors. If you want to think about what this looks like, let's use a little example here. We have data, something we've observed. Well, that's nice, but what does it mean? Well, we observe some more data. And once we have some data, more than just a little bit, more than just a single piece of data, an anecdote, then we start to form maybe a theory to explain all this evidence that we think is related to the question we're interested in. Now, that looks like a nice theory, the triangle theory, but it turns out that's not the only thing that connect all these dots. There are numerous others, and this is just a small sample of frankly, an infinite variety of ways of connecting these dots. There are other competing theories. That's obvious. But what can we do with that? What we want to do is make a decision about which ones we would tend to prefer, and we use a principle called parsimony to make us prefer simpler theories rather than more complex theories. And the reason for this is we don't want to call into use any mechanisms or ideas that are not necessary to reproduce the data. Calling those in is redundant and creates potential problems down the line. Now, that's not to say that parsimony is a logical rule for deciding how the world works. That's not it at all. Parsimony is a guideline for how we should proceed forward when there's a large number of options on the table. Deal with the simplest ones first, and if the simpler theory can't continue to explain data, then we add whatever layers of complexity are needed to get to an appropriate description. So parsimony guides us, but it does not rule us. In this case, parsimony would lead us to removing everything but the triangle and the three-legged one because they're roughly similar in complexity. But the other ones can't be ruled out yet. So what we'll do then is we'll choose an experiment to rule out theories, to try to falsify them. We start with one of our two relatively simple theories. We'll start with this three-legged theory. And we want to try to falsify that theory. Falsify. It's a strange word, and your book has a good explanation of it also. Falsification means that it's possible for us to gather data that does not fit the theory. That is, it's possible to get data that will rule the theory out. Now, this is real counterintuitive for a lot of people. You would think that you want a theory that can't be ruled out. Doesn't that make it powerful? No, because a theory that can't be ruled out, a theory for which anything you observe can be argued to fit, really can't be falsified. Theories such as, well, that's the way God made it, while not questioning the existence of God either way, is not really much of an explanation either, because that can be said about anything and doesn't help us understand this particular issue that we're studying. What we want to do is have a theory that specifically helps us to understand this problem. So with the three-legged theory, we would expect a new piece of data to show up in this middle position, or anywhere along those lines, but the middle position is a good one to talk about today. If we anticipate, if we find data there, then that's where we anticipate to see it. But if the data shows up out there when we try to gather it, well, that theory is falsified. That doesn't fit the three-legged theory, does it? Some other theory must be going on. Maybe it's this theory. Maybe the theory of the Pentagon is a better theory. So what we've done by gathering more evidence is said, you know what, that triangle theory and that three-legged theory, they don't work anymore. They won't fit this data. We need to use either the Pentagon or the star theory, one of those two. Well, the star theory is a little bit more complicated than the Pentagon theory, so we're going to tend to lean towards it. But in all honesty, we can't rule out one or the other of those. Still, we stick with the one that is simpler and we go forward. And we have a theory, and it's explaining a good bit of data now. Here's the thing. The theory is not reality. It is an explanation. Reality is an independent thing that is out there, that we're trying to understand, that we're trying to come up with a description of, an explanation of. Reality may well be a circle. Key thing is, we don't know. We don't know the theory. We're going to keep gathering data. Just because we have a theory that's working for a certain amount of the data, maybe a large amount we've gathered, there's always more data that can be collected. So we're going to get more evidence, and we're going to try to revise our theory further. And we may find that it becomes now something that looks like a 10-sided diagram. Wow. I mean, that's getting kind of complicated at that point. We may decide, in fact, that even though we don't know what the reality is, that a circle is a simpler description and lean towards the circle. We don't know if we've ever actually landed on the reality. We never really know that. But once we get to the point where we're gathering so much data and it keeps coming in consistently, even if it's not literally the truth, it sure walks like the truth and quacks like the truth. So we probably ought to treat it as the truth. And that's how a lot of big theories in science work. We're talking about the theory of evolution by natural selection. That is a theory that works that way. If we're talking about the theory of gravity, that's a theory that has that characteristic to it. And there's numerous other theories that we have about how our world works that have this characteristic of, probably don't know exactly how they work, but we're pretty close. By the way, in case you're unaware of it, a new theory of gravity has come out in just the last few years. It's kind of complicated, so I'm not going to ask you to try to understand it. I looked at it, I didn't understand it. But it's intriguing to know that even after all these years, we keep refining our thinking, even about things that we think of as relatively decided. That doesn't mean we were wrong before. Our theories of gravity got us to the moon and back, right? But we're always working to learn and understand better. So when we talk about the various ways we can measure things, there's a variety of methods we can use within the scientific method. And for social science research, these methods are non-experimental or experimental. And we're going to first talk about the non-experimental methods. What non-experimental methods can tell us is about the relationship between measurements we have in our study. Measurements are things that we give them another name. We call them variables, things we've measured. Height, weight, speed of walking, level of narcissism in a person, the degree of talkativeness of a person, their creativity of a person, the anxiety of a person, the excitability of a person, and so forth. There's many things we can measure, and all of them we would call variables in a study. But what we can't do with a non-experimental method is tell us anything about cause in the terms of what variable leads to a change in another variable. We don't know which direction things go. For instance, we could be observing people walking across campus, and we'll notice that people don't tend to bump into each other. as they walk across campus, across all the sidewalks and all the intersections and everything else? Well, except for a few people. Some people are carrying cell phones. But here's the thing, while it's intuitively very appealing to think that the people that are bumping into others that are using their cell phones, that the cell phone might be causing that to happen, the fact of the matter is, simply observing like we were doing isn't actually telling us what's causing what. It could very well be that persons that are using their cell phone have a unique personality characteristic that makes them attend to the world differently. And whether they were using a cell phone or not doesn't have, lead them to still bump into other people more. Now, the fact of the matter is, the same thing that causes them to be more likely to bump into others could be something that's causing them to use their cell phone in public more. And so we don't know that the cell phone's causing the behavior because it could be something else entirely. In fact, there's examples of these kinds of relationships where the cause is actually going the other direction, even. These kinds of studies that are non experimental are case studies, naturalistic observation, surveys, archival research, and longitudinal and cross sectional studies. A case study is when we examine a single individual or a single situation and go into a great deal of detail in understanding the various characteristics, facets, influences that we heard about or were able to determine by our observations. Naturalistic observation is when we make some kind of observation of what's going on out in the everyday world, such as watching people walking across campus to note how often that they run into each other as they walk through the various intersections and so forth. A survey is where we create a questionnaire and send it out and ask people a bunch of questions about their background. We can learn about the landscape of thinking and attitudes and behaviors and orientations that people may have and how prevalent they are in our society and which ones tend to go with each other, relationships. We can do archival research. We go back into old and existing data sources that were not originally collected for the purposes we're now putting them. For instance, a few years ago, I went into the Library of Congress and gathered data on the letters to the editor that were sent to newspapers in the Salt Lake City area during the 1992 election season. I was curious about some factors in terms of relative interest in the political campaigns. Letters to the editor are still done, but they're not as prevalent as they used to be in giving you a sense of public attitudes about things. Now we would look at the comment sections on websites and be skeptical of them because you tend to get really extreme opinions. Of course, that's what you got in the letters to the editor then, too. There's also longitudinal and cross-sectional studies. Longitudinal and cross-sectional studies are studies where you watch people over a long period of time for a longitudinal study, from birth through childhood, middle age, and later into death. And so you watch them to see how they change in various ways that you may be interested in. Personality changes, attitudinal changes, product use changes, and so forth. A cross-sectional study is simpler in some ways. You're still trying to answer the question about how people might be different from age group to age group, but instead of doing it across the entire span of people's lives, you measure people through a cross-section of society where you get younger, you go out like next week and you gather younger people, middle-aged people, and older people and see how they vary on your variables of interest. These particular kinds of studies, longitudinal and cross-sectional, are much more popular for use in the developmental psychology area where we're interested in how people change and grow over their life. Experiments are the gold standard, that's our goal. Our goals are satisfied mostly with experiments. And it must be said here that experiments is one of those words that is used casually in conversation to mean a scientific research study. But not all scientific research studies are actually experiments. There's only one particular thing that is an experiment. It has certain criteria that we're going to talk about here. When you talk about experiments, these are what you're talking about. Other things are studies. Now, correlational studies only tell us if two variables are changing with each other. We can't determine cause. But experiments allow us to manipulate and rule out other explanations. And from that process, we can determine cause. There are certain features that have to be present for us to be able to make that kind of statement about cause, where one variable is shown to cause the outcomes in another variable. These features are two or more manipulated, managed conditions, meaning that we have created a situation that we can adjust the level or amount of an experience a person has. Maybe we put them in a moderate temperature room and in a warmer room because we're interested if the amount of aggression they show towards another research participant depends upon how warm the room is. And I can carefully control that. In fact, one of the key things also in this is that the difference between the conditions in the study that you're creating are only on the manipulation, that everything else is kept to the same as possible. The same room is used, the same research assistants are used. They say exactly the same things, except that which is necessary to change for purposes of causing a manipulation to happen. And finally, and probably most importantly, you do random assignment of participants to the conditions in the study. Now, this is not the same thing as random selection. Random selection is gathering people to get into your study, and that helps you to be able to say that what you've gathered in terms of data applies to the large body of people that you did not actually measure. Random assignment is once you've got people in your study, determining which of the two or more conditions you have in your study the participants will experience. For instance, if we're talking about the cell phones and walking across campus study, if we want to be able to show that there's a causal relationship between cell phone use and the chances of a person running into another person walking across campus, what we would want to do is, after gathering our people for the study, is randomly assign people to use for a walk, maybe across the quad at FSU, to use a cell phone texting with someone as they walk, and other people to randomly assign them to not use their cell phone as they do the walk. And we observe them. They don't know what we're observing them for. We tell them we just want to see them walk. We're curious about how people walk. And we observe them and we count how many interactions we have that are near misses or hits in terms of running into people using their cell phone or not using their cell phone in the two conditions. Because of that problem I mentioned earlier, that certain people may be more likely to use their cell phone, which could also be the reason they're more likely to run into others, if I've randomly assigned people, then that should not be systematically connected to one of the two conditions in the study. I've now randomly distributed that particular personality uniqueness across the two conditions of my study. Some of the people that are maybe oriented towards this personality characteristic that would make them more likely to use their phone, well, they're being assigned to the condition to not use their phone. And some people that don't have that unique personality thing that might be connected to using your phone and running into people, they're being assigned to not use their phone. And so you have both kinds of people, so to speak, in your two groups. And so what you're really looking for then is, do the two groups differ in how likely they are to run into each other as into other people as they walk across campus? And what we would hope to find, if our theory is correct, that cell phone use is connected to a lack of attention to your outside world and therefore a greater likelihood of having an accident while walking, well, that's going to be revealed as being causing of that outcome because of the fact that we've done random assignment and gotten rid of all those personality things that might be unique about the people. That's why random assignment is critical. Our goal is to show that there's a causal relationship. That's why we do this. We want to show that our independent variable, in the case of television type being watched, influences changes in the dependent variable of violent behavior displayed, something that a lot of people are going to have a hard time agreeing with, but we've demonstrated over and over and over again with studies is the case. We can do it because we can show that we have control over the outcomes. We can show that by varying the type of television that people watch, by having some people watch a violent show, other people watch some kind of daytime drama, other people watch a game show, other people watch a talk show, other people watch a reality show, and so forth, that only the people watching the violent show are more likely to engage in violent behavior later. We can show that in studies, and by systematically varying that independent variable and showing that it's connected systematically to the dependent variable and doing random assignment of people to the conditions of the independent variable, we show that we have control over the violent outcomes. That is the power of the experimental method. And therefore, we're able to say we not only are able to control it, but we know how it's happening. We're gaining insight into how it's happening. Of course, it's an imperfect insight. Remember back when we had a pentagon and the reality that we didn't know and couldn't know was a circle. The same thing's happening here. We have insight, we have a working theory, something that helps us to make predictions, but it's not perfect. We have to keep working and gathering more data and refine our theory. Of course, all of this depends upon measurement, and measurement depends upon two key concepts that have a lot of different elements to them. And these key concepts are reliability and validity. So what I want you to do now is pause the video again and go step on that scale again. It's been a few minutes since we started this, and I'll wait a moment. Welcome back. Are the numbers identical? They might be identical. They might be a little bit different. But I wanted you to go through that exercise to get a sense of what we mean by the concepts of reliability and validity. This is a key thing for understanding how we measure and what we measure, and how measurement is, well, a little bit imprecise no matter what. If you're like me, you probably had the numbers change a little bit from a few minutes ago to now, because our scales are imperfect. It's not always going to give you the same exact reading. Depending upon your scale, which may measure to the nearest pound, to the nearest half pound, or the nearest tenth of a pound, if it measures to the nearest tenth of a pound, almost certainly the measure came in differently. If it measures to the nearest pound, it probably came in the same. So that's part of the reason you may have similarity in numbers. It's part of the reason you may have differences in numbers. But reliability and validity are key elements that are linked together, but they're not the same thing. As you can see from this graphic, you can have a measure that is both unreliable and invalid. The data points you gather are scattered all over the place, and they don't tend to cluster towards the goal, the center, the target in the middle. You can have a measure that's not reliable, but is quite valid, which is a very strange concept, and in fact is hard to get at, where the data is scattered all over the place, but it is surrounding the target. We would generally consider this a very bad measure, because even though it's surrounding the target, it is not clustering towards the target. And while this is literally valid, it's not practically valid. It's not very useful. We can also have a reliable but not valid measure. It clusters very nicely, but in point of fact, it's clustering very nicely away from the target, away from where you're trying to measure things. And you can have something that's both reliable and valid. This is what we ideally want to see. What we mean by reliability is the extent to which a measurement is consistent, that every time we measure it, we get a similar value. And what we mean by validity is the extent to which the measurement method actually measures what we intend, the target, the center, our goal. So, what we would like to have is both, but we tend to have a little bit of error in either. When you're talking about measuring something like weight or height, these things are much easier to accomplish. But in psychology, we're trying to measure things that are much more difficult to measure. Things like narcissism, anxiety, frustration, creativity, and so forth. These things are much harder to measure, as you might imagine. It's harder to know if you're actually hitting the target. It's sometimes hard to know if the target is even something that can be measured. And so, in psychology, we've got extra layers of issues to deal with in our measurements. That doesn't mean we can't. We don't just throw up our hands and give up. But we accept that we have a certain amount of issues that we have to deal with that some other sciences don't have to deal with. Finally, we want to talk about ethics, not because it's the least important thing, but because it is vitally important, and sometimes the last thing you hear is one of the most important things you'll take away. Our main issues when it comes to ethics is the principles of dignity and safety. Treat people in such a way as to recognize their full humanity and their full agency to make decisions. You want to make research decisions that are going to lead to positive outcomes for people. And you want to make sure that nobody is harmed, or any harm that does have a potential of happening, you have ways of minimizing, mitigating, repairing, or eliminating. Because, well, let's face it, doing surgery, and you want to do research on surgery, you're going to harm someone because cutting into someone is harm. The question is it being done as a necessary thing, and is it ethically appropriate, and will you do appropriate remediation? Whenever we do research at a university or other institution that has involved in research, it must be evaluated by the university or institution's institutional review board. If it is an animal study, it's going to be reviewed by the Institutional Animal Care and Use Committee. The names for these things can vary a little bit. Frostburg State University has both of these institutions. Their main job is to analyze, is the study that's being proposed going to treat people respectfully and properly, and is it going to treat them safely? It does not actually tend to analyze the study from the position of is it scientifically valid, though maybe it should. That's a question that's being debated in ethics circles right now. That maybe we should not do research studies when the um, when the study is not going to yield good results because it's not very well designed. That's only come up in the last couple of decades, maybe last 10 years. I have a feeling in the future we're going to have to demonstrate we're doing not only safe and work that is treating people respectfully, but is also worth other people's time and money. I'm going to leave you with this on ethics, a little bit of humor at the end of it. Calvin and Hobbes, it's been around forever. A great study on, a great cartoon on ethics. And I will let you pause the video to read it as long as you want, of course. I'm going to end it here. I hope to see you next time.